Okay, so good morning, everybody. Greetings from Italy, by the way. We're doing good, let's say good, according to the situation. This session is about a little bit of what you can achieve with WSL and a scenario that we've been working on for a few years. So, thanks for having me here. My name is Francesco. I'm a senior premier field engineer at Microsoft, which means that I traveled from big enterprise to big enterprise, sharing my passion and knowledge on Microsoft technologies. And I've been working on WSL since forever. And Marco?
Hi, and I'm Marco. I'm working as advisor engineer at SoftJam in Italy. It's a Microsoft partner company. And I'm also involved as a Microsoft MVP in the community to showcase many things about more or less everything about the ecosystem in Microsoft and specifically for the IoT. So then, Francesco.
Yeah, we've known each other for like a few years, and it is related. The story we're about to let's say share is started a few years ago. We've been knowing each other for a decade or so. And the day we met at the Microsoft, I think it was a Microsoft event, well, a community event. We're both active in the community. I'm a former MVP, so you can imagine. And we were talking about IoT, and at the time, the WSL project was still in an very early adopter version, like an alpha version or something like that. And we were discussing about the IoT challenges. And Marco told me, we just moved from one development model to another development model, and we have facing these challenges. We are working on this. We have a few problems in mixed environments, and we talked a little bit more, and we agreed that maybe we had a solution already in place. So to give you a full picture, we have to start with a historical point of view. Because IoT, and Marco knows this very well, he's been working on IoT and on embedded devices for more than 20 years, probably. And that's my main source of information on this, by the way. And I've been working on integration with the Linux world from Microsoft for 15 years, something like that. Back in the days when there was a component called Interix, which was part of the Microsoft services for Unix. So it's been a very long journey. That's one of the reasons you can hear I'm a little bit emotional right now, but okay. So let's start our journey, and we have to start a few years ago, like 10 years ago, or even more. Not sure if my slide are many more years ago.
Yeah. I think we have to think about 1996.
Okay. Back on your IoT journey. And you were working on very, very interesting, let's say, ecosystem. Well, but back in the days, we had a different, it was a very different world, a very different environment. And you were working on something like this. You can see the slide because I see there's a little bit of delay, but give it a second, it's going to load. But you were working on a very old, and whenever the slides will show up, we'll see from the logo style, a very old system called Windows CE.
Yeah.
Just to Yeah, just for historical reasons. Go ahead. Give us an overview.
Okay, just for that, because I at the time when Windows CE was born, probably you were still at the primary school, I think. And yeah, what we are talking about, Windows CE for most of them probably is something that is just not known, or something that we can recall in the very, very long time. Well, describe what Windows CE is not so easy, because Windows CE or Windows Embedded Compact, considering that the product has have a lot of change in the name, was born in 1996, essentially, and is an operating system that at that time was born for the objective to create a multi-platform operating system, very light, with a lightweight dimension, that will target essentially and specifically the embedded market. At that time, we talk about the embedded market. The main point was that that need to run on very low memory board, and guarantee also hard real-time feature. For that time, talking about hard real-time was simply a dream, because in many cases, for having real-time properties in an hardware environment was very, very, very difficult, and we have to build everything from ground up for our system. In this case, this operating system was built from the ground up in the way that is mainly a componentized operating system. So I can decide to build a BSP, a board support package, that essentially is the image of the operating system, getting only the packages I only need for my device. In that way, I can build many different type of operating system, different operating system that can afford a different task for different devices. And mainly this feature permitted to build, as you can see in this slide, many different, let me say, incarnation of the operating system, because we have a specific version for the smartphone. The more knowledge is Windows Mobile, Windows Pocket PC, or smartphone version. Or the other was Auto PC, for example, or in the not so distant time, the Zune, or other. I prefer not to make the long list.
When you mentioned it, that was painful.
Yeah. It's too long. So the main point was that essentially for building application and building this ecosystem, was decided to introduce a specific version of the .NET framework. The Compact framework is the name. You can remember that also in the time of in the first time of Windows Phone in 2010. At that time, Windows Phone, the first incarnation of Windows Phone, was based on Windows CE. And .NET Framework, what is a rewriting of the framework, but specifically with the memory constraint and low resource in mind. So all the API and in the framework that was available in the Compact framework was written essentially to having speed and efficiency that was running on a very small board with a very low memory. And also the architecture of the operating system respect this approach. As you can see, over the hardware, there was all the part that depend not only from the hardware specification. So in that case, the device driver and also the layer that depends from the builder of the hardware, but also some specific part that the Microsoft at that time already provide. Over there, the real operating system part, where we have APIs, the kernel, and also the other part that specifically define the characteristics. Essentially, the main one, as I already said, was in the feature of having hard real-time properties. And then another I can say revolutionary way to work with this operating system also was the way we can build the operating system and the application. So the development cycle on Windows CE was defined essentially in a couple of tools that in the years started separately, because in the first timing the tool that's its name, platform builder, that was the tool that we used to get each package of the operating system and create the specific BSP for a specific board, was integrated in Visual Studio. Essentially from 2003 version and 2005 following version, the platform builder and the development platform for the Windows CE was integrated in totally in Visual Studio, where from that time on we can build all the operating system inside, the driver, develop the driver for the hardware, and also build, create, write, test, debug the application of our device system whatsoever. And from inside Visual Studio, we have the possibility to create the operating system image, test it, debug it, and also deploy directly on the device, and also test the application on the device directly. That's, for that time, was an approach that was very important, because at that time, for the embedded market, every board have its specific development environment that you can only use for building for that specific board. And for that reason, this approach was fantastic and had a lot of followers in the market, and consider that Windows CE is probably one of the most diffused operating system in the embedded and industrial field now. considering that the last emanation of Windows CE is Windows Embedded Compact 2013, that continue to be supported from Microsoft, but essentially there not will be a new incarnation of these operating system. And that's the reason that Microsoft start telling about that will not be future incarnation of the operating system, that started to get us to new thinking about. Going to the next slide, please. And essentially, we started to don't have certain trail for the platform. And essentially, many other companies started to, on the market, started to look for other environments. And I'm talking essentially about Linux. And at that time, there are many incarnations of Linux, but essentially in the embedded market, there was essentially one, that is Linux embedded. After that time, and in the last year, many more has come. For us, one of the main problem that we have to manage was that we need to build customized image distribution for our devices, because we don't use a lot of different hardware board, but we target a lot of different devices and applications. And for that reason, we need to have a different kind of distribution that can target specifically the specific device. And another thing that starting from the time I'm talking about, so about 2010, 2013, that years, we start to see that also the OEM, the hardware supplier, started to breed the support and giving us a meaning and giving us the availability of BSP also for Linux distribution. And that's the reason why we started to think about to move our experience, our application, our system versus the Linux environment for embed. And what's happened now? As Francesco already said, I talk about it to Francesco, and Francesco suggests me something.
Yeah, we met. It was probably 2016 when you first mentioned what you were working on. So the situation was something like this. You had embraced the Linux ecosystem as an embedded environment, along with your Windows ecosystem, and you chosen a very interesting platform, which is the Yocto. Not sure if I'm pronouncing it correctly. Sorry about that. And you actually described me a nightmare scenario, because from a development point of view, you had to double everything, because you have your old, well, let's say old Windows developers that were they were working on the environment they already knew, which was the Windows environment. They switched from Windows XP then to Windows 7, and at the time it was Windows 8.1 and started using Windows 10 with different versions of the Visual Studio Suite and other tools. And on the other side, on the other hand, you had your Yocto environment, which is 99% of Ubuntu developers. And a few developers, since you were developing in, and you're still developing in C, C++, and something like that all the time, you have people with multiple workstations or with multiple booths. So you have your development environment and your other development environment for the same essentially the same product, because your two boards with different configurations sometimes need to integrate and communicate with each other. So for the same product, you had different environments and you have different tools. Since with the Yocto environment, you described a very complex embedded architecture and very complex embedded deployment and development workflow. With a lot of tools that only work on Linux. So this is the scenario. This is how actually they were working at the time. So a Linux group and a Windows group within the IoT development group, very complex to manage and a nightmare from a development point of view. And people switching from one computer to another, and then they started working on virtual machines. But virtual machines are not good for IoT development. It's not the best option for two reasons. First one, if you're on Ubuntu, you usually need to use the QEMU option, which doesn't work very well on a virtual machine from a performance and from a compatibility point of view. And second, because if you have to talk to a device, it's very complex to do that from a virtual machine. From another point of view, having a dual boot, it's just a nightmare, but I think everybody knows that. It's such a nightmare that you're not even able to start and finish your work on the same environment. And then there was your deployment scenario that you were you were following just a standard deployment scenario, but you didn't have a consistency of tools, a consistency of test sequences, a consistency of workflow, because you had the workflow for Linux and the workflow for Windows, and a variety of tools that actually did the very same thing on different platforms, and you didn't have any decent porting that allowed you to use the same tool on the same platform. So different environment. And what I saw was that all your developers were using different tools, not even the same development environment. The other challenge was you were building your infrastructure and targeting all your devices with a lot of scripts and automation, which is a good news, but it's not very good news if you have to be on a specific operating system to run that scripts, because it leverages on a few components that are not available to all the systems. So that was the very the big problem that you were facing. And I was, at the time, I was working on a very interesting component called WSL, or a strange subsystem that was just in a technical internal preview. So what changed, and what you did change with using WSL? So first of all, let's see all the aspects. We've divided it in tools, the development environment, the deployment, and we have a few notes because it's an ongoing process. We're still working on this. But essentially, first thing, on Windows, we had all the legacy tools and processes, and we started with a pilot. So let's take a Windows 10 box, let's install WSL. It was even a beta at the time, WSL version 1, not even WSL 2. So with just the user mode. We installed it, we started with the development tools, and we selected, since all the Windows developers are using Visual Studio, let's try Visual Studio Code, which is the portable and multi-OS, multi-platform version of Visual Studio. It's a lightweight version, it's not the same Visual Studio. And let's try to use that. So the integration between Visual Studio Code and WSL is just fantastic. So we had the same environment, and second step, we went on the Linux environment. They were using Yocto and a lot of tools, which of course was 99% Ubuntu, and QEMU for making the devices emulation. And the first challenge was, okay, does it work on WSL? And so we opened up a case and we started talking internally. And yes, QEMU actually can run on WSL on certain levels. So we had this strange migration of developers that started using a Windows environment with WSL to develop for the Yocto environment. Very, very interesting. Of course, on Ubuntu it was easier, still easier, but when they had to switch, they didn't have to make a complete context switch just in their mind. They just opened up Visual Studio and switched from one window to another, and with F5 they could compile the solution they were working on. The second step was for your workflows. So in the deployment phase, you have to deploy your software or your custom image to the device. So you, in the past, you had to select is it a Yocto image, is it a Windows CE image? Right now you have just one image, and we started migrating all those scripts like bash scripts that leverages on specific Yocto tools that only runs on Linux, on Ubuntu, on WSL. And we found that they actually work pretty well because they just needed to be installed as part of toolkits that you can make an apt install and have it on your environment. Then for your source management, your repository, you had a Git for a local Git repository for your Linux world, and DevOps in the cloud, an Azure DevOps in the cloud for your Windows environment. And then we switched on. Let's try to make to unify everything, and we switched on GitHub for both the worlds, still leveraging on DevOps, but we moved that, and we managed to remove all the virtual machines. And now we have a lot of users in a very interesting environment. This is a very easy scenario. You can see from my next steps that we were still working on it. We're working on two different environments. One is Windows 10 and one is Ubuntu. Windows 10 is the base. It's just a, let's say, built-in configuration for the developers. So if you are a Windows and Yocto developer, you install Windows 10, you've got Visual Studio, you've got WSL, you have everything you need, and you don't have to change your environment. and we called it BYODE, bring your own development environment. So if you need to use your tools, those are available. If you are just an Ubuntu and want to use Ubuntu, of course, go for it. We'll also give you access to the GitHub, and you have your Visual Studio Code, and you can interact with others. Since if you only need to develop on Linux, we have no reason to use Windows 10 if you don't need it. But the other thing is that we're not talking, of course, only of embedded devices, but Internet of Things. And since you've been working on Windows and on Azure, so we're talking about the public cloud, you have all the integration also for those kind of services that are from the cloud. So the current very easy deployment scenario looks like this. Okay, it's a very easy step. We called it unified deployment. We took a series of scripts, and you can actually see a series of scripts that when you press F5 on your device, or virtually pressing F5, it's a little bit more complex than that. You start a series of scripts that, if you're on Linux, are the very same scripts that you will run on WSL, and you'll have your device ready. For complex scenarios when you need to have two different devices, one on Windows C and one with the Octo that needs to integrate and to have communication with specific versions, because they have to match the version for the protocol to be supported and work just fine. We have a single deployment of customized OS on that. That's performed on a Windows 10 box that runs a PowerShell. The PowerShell scripts runs a few commands for the Windows device, then starts WSL, runs a few commands in WSL, make both deployments, and gives you a feedback on the health state of your devices. Any final notes, Marco, from your point of view?
No, I think I have approached the right engineer for having the solution of my problem, and I can only say thanks to you, because I think I still will having 7 or 10 different build pipeline that. And for that reason, I think it's very nice, this solution. So,
yeah, well, I have to give you an apologies, guys, because we actually have prepared a few boards for you, but we tried in the previous days to make to show a demo of the board, but we weren't able to make that visible from a virtual conference. So sorry about that, because we're not even in the same room. We're isolated on different cities, and that make it impossible to show you the live demo we wanted to perform, because
the thing became a bit the thing became a bit complex. You can understand.
You can run a cable. But so we'd love to on time, because supposed to
probably we are on time, and probably we have some time also for a question.
Yeah. So a big thank you for having us here. And if you have any questions, I think we have time. Otherwise, you have our contacts. So if you have questions, or if you want to have more information on how we did it, feel free to contact us. Thanks very much.
Thank you.
Thank you, Marco and Francesco. And we have one question from a community member, Sean Kelly. How do you manage low-level access to embedded targets in your workflow? OpenOCD flashing via existing make files, or JTAG debugging, for example, from within WSL?
Essentially is part of the thing that also we will. If I'm not wrong, we see that also in in a small part also yesterday in the session of the development, C++ development in Visual Studio. More or less, we use the same approach in that case. And we, in that way, we also have the possibility to not only deploy, but also test and debug directly on the device, on the hardware.
Very good. Interesting. Yep. And then he commented that USB device access is one area where VMs on Type 2 hypervisors seem easier than Type 1. Would you agree?
Well, this has been a request on Hyper-V like forever, like give us USB device access, and we have had even more difficult problem than that because we have to work with the serial, not even a USB. So
Right.
that was even, yeah, even, but yeah, sure. But you know, if you want decent performances, the hypervisor Type 1 is the only way. So that's.
Yeah, but in the embedded system, we work about serial, not USB.
So what kind of data throughput can you get on a serial connection? Has it come faster from RS-232, 2400 baud?
No, essentially the RS-232 to 32 is essentially used for accessing via terminal. So you can in SSH and having a terminal access to the device where you can run instance, load package whatsoever. On the other side, on the back side, if you have the need to transfer big amount of data, or also for the debug session, you can also use the TCP port and use Ethernet and the Ethernet connection in that way.
Yeah, I remember you even demonstrated, you demoed to me one when you use a board with a Wi-Fi connection for exchanging data. Yeah,
that's very harmful to do it.
Yeah. And then one final question. Can this be used with Buildroot? I'm not familiar with Buildroot. Are you?
I'm not.
Yeah.
no, I didn't get that. Sorry.
Yeah. Maybe after, maybe you could follow up with Monty in the chat.
Oh yeah.
That question.
Oh, build. Oh, we haven't tested that. Very interesting question. Okay. Ooh, we can totally check that. But I think because this could work. Ooh, very nice input. Thanks very much.
Okay.
I'm taking notes.
And we have your Twitter handles up on your slide. Is there anywhere else folks can find you? How can they reach you if they need more detailed questions?
Contact us also offline. No problem. Thank you very much, and have a good conference.
Yep. Thank you, Marco.
Thank you.